Yeah, well, the more you do it, the more you're like, oh, okay, I got it. Yep.
I went to Khan Academy.
What's
Crystal now.
What's
I
that?
said I went to Khan Academy. It's pretty legit.
Good. Khan Academy, good stuff.
Yeah.
He is so smart, very good. I'm glad to hear that. And then, like other things in chemistry, he's got it.
I went to him for the, well, we had to convert the.
So like a tutor and
Yep.
Everything. He's tutor on life.
He is. He knows everything. So this is just a review slide of kind of the 3 steps. They aren't really like sequential steps, but generally how do we work problems using the factor label method. No naked numbers. You always have to have units with everything. And the cool thing is you're looking to set up your problems, so your problem, and I usually set it up all kind of strung up together, terms strung together, so that you get the units that you want in the end. That's it. You let units cancel that are in both numerator and denominator, and you're left with the units that you want to be left with. And so we did this one where you guys told me 2.5 feet is equal to 30 inches. But to do it the factor label way, you have to do this. 2.5 feet is our first term, no naked numbers. We're trying to go from feet to inches, so we know that 1 foot is equal to 12 inches. We can know that as an equivalency statement. This term right here is what we call the conversion factor we get from 1 foot is equal to 12 inches. Okay? So 1 foot equals 12 inches, that's flat. We want to use it so we're left with inches and feet to cancel, so we're going to put feet on the bottom. And then I think we had time to do this one. Did we do this one too? So the more you get these in your notes, the way my lectures are for, and I see you guys, a lot of you guys doing it, make sure that you get the problems in your notes. And that just sort of doing this for you, hopefully will help it sink in. So you're supposed to memorize 1 inch is exactly equal to how many centimeters? 2.54 centimeters. Very good. Okay, so that's an exact relationship. Cool, by definition. So then we worked this problem. So I always start with the thing I want to convert to the far left, and then I kind of string things up. And in this case, I want centimeters to cancel, so I'm going to put 2.54 centimeters down there and 1 inch there. Okay, so centimeters cancel, I'm left with inches. And then we need to round according to, I think you guys told me, 3 significant figures there. There's no uncertainty brought with the whole inch is exactly equal to 2.54 centimeters. Okay, so 3 sig figs looked like this. And that's where we left off on Wednesday. So we're going to do a few more of those. Now, what those both had in common was we just simply had the first term was the thing we want to convert, and there was like one equality to basically get from old units to new units. There was one equivalency statement. We could do that. Now we're going to take it up a notch. So on Wednesday, I gave you a slide that had 3 equivalency statements, and there was one equivalency statement between pounds and grams. Okay, it's like 1 pound is approximately equal to 453.6 grams, something like that. So you don't have to memorize that. But if I give that to you, notice that we're going from ounces, which is English, and we want to go to grams. But can you go from ounces to pounds?
Yeah.
Okay, good. Me too. Go from ounces to pounds. So what 1 pound is equal to how many ounces? 16. Yeah. So if we can go from ounces to pounds, bless you, then we can go from pounds to grams using that equivalency statement. So in this case, we're actually going to have 2 steps. So if I kind of show the flow of the problem like this, we're starting with ounces, and you guys told me that 1 pound is equal to 16 ounces. Is that exact? Yeah. That's exact. 1 pound exactly equals 60 ounces. And then there was that approximate one from a previous slide. So now we want to go from pounds to grams, and we can do that with 1 pound is approximately equal to 453.6 grams. So that's our strategy. So what's our first term on, bless you, what's our first term on the left going to be?
First.
Yep. I heard somebody say 2.75 ounces. I usually put it over 1. The reason I put 2.75 ounces over 1, it doesn't matter. I don't have to put it over 1. But if I put it over 1, then I'm emphasizing that I have units of ounces in the top, or the numerator. So if I want ounces to cancel and I want to be left with pounds, how can I use this to my advantage?
Put 16 ounces on the bottom of the equation.
Yep.
That way it cancels out with the 2.75.
Yep, put 16 ounces on the bottom of in the denominator, 16 ounces in the bottom, and 1 pound on top. 1 pound is equal to 16 ounces. Remember I talked about you can divide both sides by 16 ounces, and you get the unit factor. Cool. Well, ounces have canceled. I'm left with units of pounds. Now I want to go from pounds to grams, so I'm on that second leg there. So how can I use this equivalency statement to get my pounds to cancel?
Put it on the bottom.
Yep, put 1 pound on the bottom and 453.6 grams on top.
So can you, because would you just times it on what you just already have? Okay, yeah, I just didn't know if we needed 2.5 again.
Yep. And usually, for chemistry problems anyway, when students talk about do I multiply or do I divide, I say, well, you set it up and let the units say what you do. So now the units of pounds have both canceled out, and the only units I've got left are what? Grams, which is a check for setting it up. Okay, so there is your check. And I think I mentioned this before, I kind of think of this is over 1, I kind of think of these 3 divisors as being kind of connected. And so what numbers-wise, I have 2.75, I have 1, and then I have 453.6 in the top. And in the bottom, looks like I just have 16 in the bottom. And units are grams. Okay, does that make sense? So then probably what I would do is open my parentheses, take 2.75 times 453.6, close my parentheses, hit the divide by key, and just simply put 16. That's how I would do it. So somebody who did that, can you tell me what your calculator said? What did your calculator display? $77.5625. 96, cool, thank you. 25, and units would be grams. Awesome. Okay. So let's look back now. As far as rounding goes, is there any uncertainty brought by the 2.75? Why do you say no?
Well, I guess, what is our 5? The 5.
Right, I'm going to put a question mark there with the 5. So
It
it,
still counts as 36.
right.
It's just uncertain.
Yep, that digit there in the tens place, the 5, in the hundreds place, the 5, it's a uncertain digit. I mean, so there's wiggle, so it does bring uncertainty to working this problem. So we have to count 3 sig figs. How about this right here, this next term? Any uncertainty in the 1 or the 16? No, why?
A 1.
That's because it's a 1, but
Set conversion.
it's a set conversion, yep. It's like a, by definition. By definition, 1 pound is exactly equal to 16 ounces. Okay, now this one right here, okay, I don't know if you've noticed, but when I said, tried to say this relationship before, I said 1 pound is approximately equal to 453.6 grams. So, is there uncertainty in the 453.6?
Yes.
Yes. How many sig figs are there? How many sig figs in, I know my thing's getting messy, but 453.6, how many significant figures? 4. I see a 4 up there. Yep. Now, in an equality like this, actually, in this case, and I kind of go back to what Becky said, in this case, we're saying exactly 1 pound is approximately equal to 453.6 grams. So we're throwing all the uncertainty onto that. So the 1 brings no uncertainty there. Okay, so it looks like I got a 3 and I got a 4, so how many sig figs do I round my answer to? 3. Okay, so I'm going to keep these first 3 digits. One of my least favorite things of rounding is when you have a 9 and you have to round it up, right? So what's the answer here? So the answer is 78, but that's only 2 sig figs. 0.0. Yep, you got it. That's it. Final answer. Okay. Any questions about that one? Okay. All right, let's do another one. So this is metric, okay? And I know in working metric conversions, usually we just move the decimal place over. But remember the instructions in the handout I gave you for your exam on Thursday say you have to work all problems like this using the factor label method. My suggestion is notice that millimeters is little and smaller than the base unit, and kilometers is bigger than the base unit. What I usually do is go through the base unit. So it's going to look like this. Let's see. You're supposed to memorize the kilo prefix. So 1 kilometer is equal to how many meters? 1,000. Yep, very good. And then I usually do the other one this way. 1 meter is equal to how many millimeters?
1,000.
It's not.
No, wait, that
It is
was
1,000.
centimeter.
It is 1,000. Yep. Yep. 1,000 millimeters. Does that make sense? That's kind of how I usually do that. Alternatively, this one right here, we could have alternatively said 1 millimeter is equal to how much of a meter? 1/1000th of a meter. Yep. Same diff. Okay, so I would actually have 3 terms, including the first term that you start with that you want to convert. Okay, so I would go through meters. I would go from millimeters to meters, and then meters to kilometers. That's just what I would do. Can you go directly from millimeters to kilometers? Yes. So what's the first term going to be? Yep, the millimeters I want to convert over 1. So this was actually, notice that this is packed up in scientific notation. So 1.2 times 10 to the 9th millimeters over 1. Now I'm going to go from millimeters to meters. So what does the second term look like? I want to go from millimeters to meters, yep.
So you put the 1,000 millimeters on the bottom?
Yes, 1,000 millimeters on the bottom, yep. And 1 meter on the top, you got it. And my millimeters will cancel. And now I want to go from meters to kilometers. So what does that look like?
1,000 meters on the bottom.
Mm-hmm.
Kilometer on the top.
Yep, 1,000 meters on the bottom, 1 kilometer on top. So in working problems using the factor label method, you make sure you get the units that you want to be left with. And if you did, then you have confidence that you can go ahead and multiply and get the right answer. So we have, 1.2 times 10 to the 9th in the numerator, and we have 2 terms of 1,000 in the denominator. So how are we going to round this? Yep, two significant figures. Yep, because numbers that are in scientific notation like this, remember we focus on the coefficient to pick off the sig figs. So we're going to round to 2 significant figures. So is this what you got? So 12,000? Wait.
Yep.
Wait. 1, 2, 3. 1,200. 1,200. Any questions about that?
Can we do it not like with the calculator?
You have to show your work, but you can do like not with the calculator for this one. But you still have to show it setting up. Part of this class is communicating how you work the problem.
You write it not in scientific notation?
Yep.
Oh, wonderful.
This one you could get by with that too, because I think like what Colin's point is, as long as you don't put the decimal point, there's 2 significant figures there too. Yep.
So. Oh, I got it.
Okay. In your homework that's due on Monday, you're going to be asked to do some of these metric conversions, and as you might imagine, it's not okay just to move the decimal place over. You're going to have to show, just like I did here, how you get from one metric unit to another metric unit. Okay. All right, let's work another
I
one.
have a question. Okay, so how
Yes.
you just put the, it was 1,200, but we have the 2 significant figures. Wouldn't this, because they're trailing zeros, wouldn't that be 4?
No. They're not trailing zeros, they're just like
Oh, they're just, because
placeholders.
there's no.
Yeah.
Okay.
Yeah, they're not trailing zeros after a decimal, there's, the
True.
decimal's implied,
Okay.
yeah. It's not.
So if it's a whole number with no decimal points, and there's 0 in it, that does not count as a significant figure?
Right. Yep. If it's a whole number with just zeros here, they don't count.
Okay.
Mhm. Unless you put a decimal there, and then they
All
count.
right, gotcha.
It'd still count if you put a decimal between the zeros, wouldn't it?
Yep, but she said a whole number, so, yeah, if you have this 3, 5, decimal, 0, 0, then they count. Yep. So the next example I want to do actually deals with, I think this one right here, the volume. So we know that between the English and the metric system, exactly 1 gallon is approximately equal to 3.785 liters. Okay, you don't have to memorize that one. What do you have to memorize here?
An inch to centimeter.
Yeah, the inch to centimeters, you have to memorize that. Okay? So if I gave, now I may not give you this one on a test, because if you're like me, I have to concentrate to get from cups to gallons. But assuming we can do that, get from cups to gallons, then we can go from gallons to liters and liters to milliliters. Okay? I guess I should say going backwards and go from milliliters to liters, liters to gallons, and gallons to cups. So that's what we have going on. We're starting with milliliters, trying to get to cups. Well, what's the relationship between liters and milliliters? What's that?
1,000 milliliters?
Yep, it is 1,000 milliliters is equal to 1 liter. Exactly. So this here in the yellow, you don't have to memorize. Okay? We kind of have a strategy here, milliliters, liters, liters to gallons, gallons to cups. Kind of smack dab in the middle, our gallons to liters. That's called crossing the empirical bridge. It's simply where we're going from, in this case, metric to English. I'm going from metric to English. There. You don't have to memorize that. You told me the first one, the first equivalency statement to go from milliliters to liters, there's exactly 1,000 milliliters in 1 liter. And then I can go from liters to gallons using that second term. Anybody know gallons and cups? I would have to concentrate. I would just look. 16. Okay. All right. So we're going to actually have 3 terms now. But what's the first term going to be from left to right?
275.
Yep.
No.
275 milliliters over 1. Perfect. Now, according to the strategy, how do I go from milliliters to liters using that relationship?
1 liter on top.
Yep, 1 liter in the top, 1,000 milliliters in the bottom. Very good. And then how do I go from milliliters to, how do I go from liters to gallons using this one?
3.75 liters on the bottom. 1 gallon on the top.
Yep. 3.785 liters on the bottom, 1 gallon on the top. Awesome. And then last but not least, I've got units of gallons. How do I finish off and get to cups with this last equivalency right here?
1 gallon on the bottom, 16 cups on top.
Yep, 1 gallon on the bottom, 16 cups on top. Bless you. Perfect. So unit-wise, we're left with the units we need to be left with. This one seems a little busy, so it looks like terms on the top are just 275 and 16. Terms on the bottom, I got 1,000, 3.785. Looks like that's it. Units are going to end up being cups, which is perfect. So let's see how we want to round it. Is there uncertainty in this first term? 275. What do you think? Is it exact or is there uncertainty?
It's exact.
Why is it exact?
Oh, no, it's not over, it's not a set conversion.
What?
Right? It's not a set conversion.
It's not set conversion, right?
So it's not.
It's a whole number, but there's uncertainty in this, in all measured quantities.
Oh, so it has to be an equivalency to be.
Right, equivalency, it has to be an equivalency by definition
Okay.
Not
To-
about.
to be no uncertainty. What's that?
When it's not about, that's you're certain.
Okay. Yes, when
they
it's
say
about, yeah.
It's uncertain.
When the word about means it's uncertain. So, yeah, so the relationship between gallons and liters is about. So there's uncertainty. So, what, 3 sig figs there. I'm liking that. Any uncertainty here within the metric system? Nope. No uncertainty here within the metric system. Any uncertainty here with the gallons and liters? Yeah. So, actually, we need to note that there's only 4 significant figures there. Any uncertainty here within cups and gallons? Nope. Very good. Okay, so we got 3 or 4, so we need to round according to 3 sig figs. Is this what you got? 1.16. 3 sig figs, 1.16 cups. Very good. Yay. All right, that's about as complicated as I want to get. other than, now I have a few things to kind of follow up conversions wise. Now this is a little bit different. You're like, I've never heard of a rod, but a rod is a legitimate unit in the English system of length. 11 yards is exactly equal to 2 rods. How many rods are there in 2.50 miles? So what you probably should do if you're working this problem, and I think you're going to see it on the next slide, is just kind of, I like to do this kind of left to right, how are we going to work the problem? So we're starting with miles, we're trying to get to rods. It gave us this in the problem. We can finish up the whole rods from yards. If we can get to yards, okay, if we can get to yards, we can finish up to go to rods with the information that was given in the problem. So do you see where the 11 yards equals 2 rods? That was given in the problem. Okay, so now we just need to get, bless you, now we just need to get from miles to yards. You might could just look that up. Most people know the relationship between miles and feet, or a lot of people. Anybody know? I just have to look this one. 5,000.
5,280.
Yeah, 5,280 exactly. Now that I wouldn't make you do in a test. Good job though. What's the relationship between feet and yards? Yes, 3 feet in the yard. Very good. Perfect. And where did you learn that from, Jared?
Remember the Titans.
The what?
Remember the Titans.
So this is how we're going to work this problem. Now the first term is going to be the thing we want to convert, 2.50 miles. How many significant figures in 2.50?
How many significant?
How many significant figures here in 2.50 miles?
3.
3. There are 3, exactly. So what's the next term going to be? I want miles to cancel, be left with feet, so I hear you guys thinking it, so I'm going to put 1 mile on the bottom. Very good. 1 mile on the bottom, 5,280 feet on the top. And then I'm ready to go from feet to yards, so what does the third term look like?
Yards over feet.
Yep, yards over feet, 1 yard over 3 feet. And then I want to go from yards to rods, and this is what was given in the problem. So what does that look like? 2 rods over 11 yards? Bless you. And that should do it, right? If we cancel, allow everything to cancel, miles have canceled, feet have canceled, yards have canceled, and we're left with units of rods. And that's exactly what we wanted to be left with. So you guys told me 3 sig figs here, I agree. Do you guys buy that actually there's no uncertainty, because it's by definition, the whole relationship between a mile and feet. There's no uncertainty, don't have to count sig figs. Of course, feet and yards, no uncertainty, and as it was given in the problem, there's exactly 11 yards in 2 rods. So rounding it to 3 sig figs, I got 800. But I need 3 sig figs, so I needed to put the decimal there. What do you think? Cool. They're fun, and it's the more you do them, then you'll become more comfortable working factor label problems. If you buy what you need to buy into factor label, because that's how you need to work problems in here, but I promise you that being able to set up problems and make units cancel and blah, 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 that actually is the crux of making chemistry not painful. That is the key to making, this is the key to making chemistry not painful, which is, I think, everybody's goal. So now I want to do a different sort of problem, factor label problem. So we have a car. If you read it a few times, there's far too many words up there, so I have to read things a few times. If you read it a few times, you see that this car gets 23.4 mpg, miles per gallon. And basically, they say it has a tank, the tank can hold 68.1 liters. How far can you go? Well, forget that. Let's just say your tank can hold, let's say you have a 20-gallon tank. Let's just do that. If you have a 20-gallon tank and you get 23.4 miles for 1 gallon, okay? What if you had a 10-gallon tank? How far could you go?
34.
Right. If you had a 10-gallon tank, you could travel 234 miles. Does that make sense? Okay. What about a 20-gallon then? How far can you travel?
468.
468 miles, exactly. So what you have done is basically, based upon the gas mileage and the size of the tank, you told me how far you can go. The only thing that's different about this problem is I'm not telling you how big your tank is in terms of gallons. I'm telling you in terms of liters. Before I move on, let's go ahead and do this factor label with these examples that I put right here. Okay, let's pick 20. That's how big your tank is. Now, I talk about unpacking. I am going to unpack 23.4 mpg. 23.4 mpg. That means 23.4 miles per 1 gallon. Right? All right. Factor label, here we come. What if I take the capacity, 20 gallons, put it over 1? Now, I am going to use this term up here in the corner here to my advantage. I'm going to have gallons cancel, be left with units of miles. And it looks just like this. 23.4 miles in 1 gallon. So what happened to the gallon units? They both canceled out. What units are we left with? Miles. And actually, that's working this problem using setting it up like you need to set it up. So let's work this problem now instead of gallons. Actually, we're going to start with liters, but do we know how to get from liters to gallons? Heck yeah. So that's what we need to do on the front end here. So, we've talked about properties and characteristics of matter. This is a characteristic of an object, a car. Do you guys buy that the 23.4 miles per gallon is a characteristic or a property? It's the gas consumption property of that car. So you need to be able to unpack mpg, miles per gallon, to use it as an advantage, as a tool to work this problem. Okay, so here we go. We're going to start with liters, convert it to gallons, and then we're going to go from gallons to miles using the gas mileage. So what's the first term going to be? Yep, 68.1 liters over 1. Very good. Now I'm going to go from liters to gallons using this equivalency statement. I want liters to cancel, be left with gallons, so what does that look like? Yep, 1 gallon over 3.785 liters. Perfect. So my liters have canceled. I left with units of gallons. Now I'm ready to use my gas mileage. I want gallons to cancel, be left with miles. So what does that last one look like?
on the bottom.
23.4 miles.
Yep, you both said the same thing, 23.4 miles over 1 gallon. Yep. So my units of liters have canceled, gallons have canceled, I'm left with units of miles, which is perfect. Now, is there any uncertainty in this first term, 68.1? Is it exact, or is it their uncertainty?
The one is uncertain.
The one is, that's where the wiggle is. The whole number's uncertain, yeah. Or, yes, that's where the uncertainty begins. So I'm liking 3 sig figs for that. Is there any uncertainty in this relationship between gallons and liters? It's approximate. There's this actually, the one is exact, but this 3.785 is approximate. So actually, if I count sig figs, I'm getting 4 there. What about this? Do you think that my 23.4 miles per gallon, do you think that's exact by definition, or is there uncertainty in that? There's uncertainty. It's like a rounded sort of thing, depending upon your measuring equipment. So, yep, there's 3 sig figs there. So I need to round to 3 sig figs. That's my point. So hopefully you got 421. You should be able now to do this problem, this set of problems. Oops, sorry. So 69, 73, and 75 will all be due. And I'm going to push some hints out. I know we're kind of bumping up against the clock. On Twitter, I recorded today's lecture, and I'll also push out some hints for working these 3 problems. There's multiple parts. My point is, these must be done using the factor label method. You need to show your work, okay? Any questions?
You don't have to do 71.
Don't have to do 71. Nope. 69, 73, 75.